Welcome back to Math Lab. I will be going over some basic college algebra graphs, really. My friend's going to take college algebra this next semester, and I thought it might be kind of nice if he has a video to watch. But I'm going to keep it nice and simple. Let's start off with a graph of f of x is equal to x. So f of x is equal to x. You know, if we, this is a line, right? This is just saying, okay, there's a line somewhere on the graph. It doesn't really matter where it is yet. Basically, there may be some other information over here. You know, let's say if it's plus 2, then it's actually going to go up 2, and then and this is where the line will start. You know, if it's minus 2, then it'll go down 1, 2. So then you have a line right here. If it's neither, let's just say it's x, then it's going to go across the origin. It's going to go to positive infinity or to negative infinity, assuming there's no domain restrictions. And you know, just to prove that to you, if we set up a little chart here, and we said, well, okay, if you said, okay, I don't really believe you, Anthony, that's not true. Well, let's see. Let's just say we have the graph of f of x without this 2 right here. Now, if I plug in numbers, doesn't matter what number, if I plug in a -1, so f of -1 is equal to -1, right? My mom's calling. I'll have to give her a call back so I can teach a little bit of math, and then I'll call her right back. Okay, so if I say f of -1, what I'm saying is, wherever in this function, wherever there's an x, I'm going to plug in a -1. Well, here I had, right here I had an x. F of x is equal to x. So if I plug in a -1, like I did right here, then x is equal to -1. Well, then if that's the case, let's just say f of x, or I can call it y is equal to -1. So if I plug in a 0, f of 0 is equal to 0. Well, then that just means that at x is equal to 0, y is 0. And 1, the same thing with 1. So if I was to graph that, at -1, -1. At 0, 0. At 1, 1. And so your line goes through the origin, up to positive infinity, and to negative infinity. Okay, so that's our line. Let's see. Let's try it. What about this? Okay, let's look at something a little different. What if I said f of x is equal to x squared? Now it's quadratic, right? In other words, the power here is greater than 1. Here we had a linear function, so the power was just 1 up here. Well, here now the power is 2. So the graph of this is just going to be a parabola. It's going to go up like so. And once again, you might say, well, I don't really believe you. Okay, well, let me show you, okay? And actually, let's just leave it like that. If I said, if I set up my little table here, remember that f of x is really just another word for y, really, okay? So this is telling me that this is where I put my input, or this is what values I'm going to put in for x, and then I'm going to put in all those values on this side. Wherever there's an x, like for example, if I put f of 0 once again, then we would say, well, okay, 0 squared. So this f of x is actually equal to 0. And if f of x is y, f of x is equal to y. Well, then if I plug in a 0 for x, well, then y is equal to 0. If I say -1, well, okay, f of -1 is equal to -1 squared. Well, that's going to be equal to a negative number squared is always going to be positive, right? That's going to equal to 1. So if I plug in a negative value, -1 for x, then I get a positive y. If I plug in a 1, well, then you could probably see if I plug in a 1 for if this is a 1, then for example f of 1 is equal to 1 squared, which is equal to 1. If I plug in a 2, it starts getting a little more interesting. Then we can see what's going on here. Then you have f of 2 is equal to 2 squared, which is equal to 4. So if I plug in a 2 for the x, for my x values, then I get a 4. So if I plug in a negative 2, you can probably see that if I square a negative 2, it's going to come out to 4. So, and it coincides with this. At x is equal to 0, y is 0. At x is equal to negative 1, y is 1. At x is equal to 1, y is 1. And at 2, y is 2. And negative 2, y is 2. So then if we kept on going, we'd get something that looked like this. Okay? I'm doing half my work, not even on the screen. I'm sorry about that. Let's see. Let's move on to another. Let's see here. All right. Let's say we have, and I don't have too much more time left, because these things take forever to download. Let's see here. We've got f of x is equal to x cubed. Well, it's very similar to when x is squared, right? I mean, it's still quadratic here, but my claim is that it's gonna look like, the graph of this is gonna look like this. It's gonna come out like that, and then it's gonna go downwards like this. And the reason why is because if we plug in the numbers, it just so happens that that's what happens. You know, you plug in a number to, let's say you plug in f of 0 is equal to, so in other words, if x is 0, then y is going to be 0 cubed, which is 0, y is 0. If I plug in f of 1, 1 cubed is just equal to 1. So at x is 1, y is 1, and so this is where it really separates though from our x squared function. Well, now if you plug in a negative 1, if we plug in a negative 1, f of negative 1 is equal to negative 1 cubed. And if we cube a negative number, well, we still get a negative number, don't we? Now let's see. Let's go on to 2. F of 2 is equal to, at x is equal to 2, in other words, we have 2 cubed. What's 2 cubed? 2 cubed is 8. So you can see if I plug in a negative 2, well, that's going to be a negative 8, right? Because anything cubed, any negative number cubed is going to stay negative. Okay? So if I looked at this and I said, okay, at 0, 0, and then at x is 1, y is 1, x is 1, y is 1, and x is negative 1, y is negative 1, we can see what's kind of unfolding in front of us here. And at x is 2, y is 8. We can call this 8 somewhere up here, and vice versa. If we do negative 2 at x is negative 2, y is negative 8. It'll be somewhere down there. But as you can see, as our x values go out, they go out a little bit. For example, they went out, the x value went out 2, and then it went up 8. So as the x values get larger, the y values get much larger, right? Because they're actually cubed. Okay, so that about is about the end of my time for now. I'm about to hit the 10-minute mark, but I hope you find this helpful. And if you have any questions, go ahead and give me some comments below, or just email me. But thanks for joining me. I'll see you next time.